My photo taste is the Pinterest because they are the best.
Welcome to Spotlight. I'm Liz Wade.
And I'm Bruce Gulland. Spotlight uses a special English method of broadcasting. It is easier for people to understand, no matter where in the world they live.
It is winter in the United Kingdom. The city of Bradford is very cold. People in the city center stop and listen. They hear the roaring sound of a chainsaw. This tool is very loud. People usually use chainsaws to cut down trees. But on this day, a man is using the chainsaw differently. He is using it to cut a large piece of ice. As he works, small pieces of ice fly off into the air. The man is carving the ice into a particular shape. A crowd gathers to watch him. They are amazed that he can make such a beautiful sleigh from the block of ice. The sleigh looks so real that the people can imagine horses pulling it across the snow.
The man creating this sleigh is Jamie Wardley. He is a special kind of artist. He is an ice sculptor. Today's spotlight is on Jamie Wardley and ice sculpture.
Jamie Wardley loves to sculpt. He first trained as a sand sculptor. He learned to create beautiful images using sand. Later, he learned about ice sculpture. Now, he does sand sculpture in the summer, when the weather is warm in the United Kingdom. And in the winter, he sculpts ice. Wardley loves working with ice. He told Spotlight,
"Ice is just such a beautiful thing. It has got a special quality about it. It is wonderful and exciting too, because it is such a strong material. You can do wonderful things with it."
Working with ice can be wonderful, but it is also difficult. The conditions must be just right. Ice melts when the air's temperature rises above 0 degrees Celsius. So Wardley has to work in cold temperatures. If the weather is cold enough, he can work outside in the open air. But winter in the United Kingdom is not always very cold. So often he works in a large freezer. The temperature in the freezer is between -10 and -12 degrees Celsius. Wardley told Spotlight,
"To be in this freezer, we wear very warm clothes. We are in there all day. I work in other places where it can be -25 degrees. So -12 degrees is fine for me."
Wardley enjoys sculpting ice outside in the winter. When he sculpts in the open air, people can watch. They can be part of the creative process. Spotlight asked Wardley what he enjoys most about ice sculpting. He said,
I think it is the creativity. You get to create something. And often with the kind of work, we get to create it in a public environment. People get to see you make these things.
When people watch ice sculptors work, they recognize the great skill it requires. Ice sculptors must also be strong and skilled artists. Wardley explained the basic ice sculpting process to Spotlight.
First, we get a block of ice. Then we mark an image on the ice. We do this with a small, sharp shaping tool called a chisel. Then we simply cut the image out using a chainsaw. We use chisels again after that, and sometimes we may use some rough sandpaper to smooth and round off edges.
Wardley makes it sound simple, but the tools he uses are sharp and dangerous, and the ice is very heavy. Each block of ice weighs 120 kilos.
My photo taste is the Pinterest because they are the best. Flick to link, a link to flick.
Hi, I want to talk about understanding and the nature of understanding and what the essence of understanding is. Because understanding is something we aim for, everyone. We want to understand things. My claim is that understanding has to do with the ability to change your perspective. If you don't have that, you don't have understanding. So that is my claim. And I want to focus on mathematics. Many of us think of mathematics as addition, subtraction, multiplication, division, fractions, percent, geometry, algebra, all that stuff. But actually, I want to talk about the essence of mathematics as well. And my claim is that mathematics has to do with patterns. Behind me you see a beautiful pattern. And this pattern actually emerges just from drawing circles in a very particular way. So my day-to-day definition of mathematics that I use every day is the following. First of all, it is about finding patterns. And with a pattern, I mean a connection, a structure, some regularity, some rules that govern what we see. Second of all, I think it is about representing these patterns with a language. We make up language if we don't have it. And in mathematics, this is essential. It's also about making assumptions and playing around with these assumptions and just seeing what happens. And we're going to do that very soon. And finally, it's about doing cool stuff. Mathematics enables us to do so many things. So let's have a look at these patterns. If you want to tie a tie knot, there are patterns. Tie knots have names. And you can also do the mathematics of tie knots. This is a left out, right in, center out, and tie. This is a left in, right out, left in, center out, and tie. This is a language we made up for the patterns of tie knots. And a half Windsor is all that. This is a mathematics book about tying shoelaces at the university level, because there are patterns in shoelaces. You can do it in so many different ways. We can analyze it, we can make up languages for it. And representations is all over mathematics. This is Leibniz's notation from 1675. He invented a language for patterns in nature. When we throw something up in the air, it falls down. Why? We're not sure, but we can represent this with mathematics in a pattern. This is also a pattern. This is also an invented language. And can you guess for what? It is actually a notation system for dancing, for tap dancing. And that enables him as a choreographer to do cool stuff, to do new things, because he has represented it. And I want you to think about how amazing representing something actually is. Here it says the word mathematics. But actually they're just dots, right? So how in the world can these dots represent the word? Well, they do. They represent the word mathematics. And these symbols also represent that word. And this we can listen to. It sounds like this. Somehow these sounds represent the word and the concept. How does this happen? And there's something amazing going on about representing stuff. So I want to talk about that magic that happens when we actually represent something. Here you see just lines, right, with different width. They stand for numbers for a particular book. And I can actually recommend this book. It's a very nice book. Just trust me. Okay, so let's just do an experiment. Just play around with some straight lines. This is a straight line. Let's make another one. So every time we move one down and one across, and we draw a new straight line, right? So we do this over and over and over. And we look for patterns. So this pattern emerges. And it's a rather nice pattern. It looks like a curve, right? Just from drawing simple straight lines. Now I can change my perspective a little bit. I can rotate it. And then have a look at the curve. You know, what does it look like? Is it a part of a circle? It's actually not the part of a circle. So I have to continue my investigation and look for, the true pattern. Perhaps if I copy it and make some art. Well, no. Perhaps I should extend the lines like this and look for the pattern there. And let's make more lines. We do this. And then let's just zoom out and change our perspective again. And then we can actually see that what started out as just straight lines is actually a curve called the parabola. This is represented by a simple equation, and it's a beautiful pattern. So this is the stuff that we do. We find patterns and we represent them. And I think this is a nice day-to-day definition. But today I want to go a little bit deeper and think about what is the nature of this? What makes it possible? And there's one thing that's a little bit deeper, and that has to do with the ability to change your perspective. And I claim that when you change your perspective, and if you take another point of view, you learn something new about what you are watching or looking at or hearing. And I think this is a really important thing that we do all the time. So let's just look at this simple equation, like x plus x equals 2 times x. This is a very nice pattern, and it's true because 5 plus 5 equals 2 times 5, etc. And we've seen this over and over, and we represent it like this. But think about it. This is an equation. It says that something is equal to something else, and that's 2 different perspectives. One perspective is it's a sum. It's something you plus together. On the other hand, it's a multiplication. And those are 2 different perspectives. And I would go as far as to say that every equation is like this. Every mathematical equation where you use that sign, that equality sign, is actually a metaphor. It's an analogy between 2 things. You're just viewing something and taking 2 different points of view. And you're expressing that in a language. Have a look at this equation. This is one of the most beautiful equations. And it simply says that, well, 2 things, they're both negative 1. This thing on the left-hand side is negative 1, and the other one is. And that, I think, is one of the essential parts of mathematics. You take different points of view. So let's just play around. Let's take a number. We know 4/3. We know what 4/3 is. It's 1.333. But we have to have those 3 dots. Otherwise, it's not exactly 4/3. But this is only in base 10. You know the number system, we use 10 digits. If we change that around and only use 2 digits, that's called the binary system. It's written like this. So we're now talking about the number. The number is 4/3. And we can write it like this. And we can just change the base, change the number of digits, and we can write it differently. So these are all representations of the same number. We can even write it simply like 1.3 or 1.6. It all depends on how many digits you have. Or perhaps we should simplify and just write it like this. I like this one because this is 4 divided by 3. And this number expresses a relation between two numbers. You have 4 on the one hand and 3 on the other. And you can visualize this in many ways. And what I'm doing now is I'm viewing that number from different perspectives. I'm playing around. I'm playing around with how we view something. And I'm doing it very deliberately. We can take a grid. If it's 4 across and 3 up, this line equals 5 always. It has to be like this. This is a beautiful pattern. 4 and 3 and 5. And this rectangle, which is 4 by 3, you've seen a lot of times. This is your average computer screen. 800 by 600 or 1600 by 1200 is the television or a computer screen. So these are all nice representations, but I want to go a little bit further and just play more with this number. Here you see 2 circles, and I'm going to rotate them like this. And observe the upper left one. It goes a little bit faster, right? You can see this, and it actually goes exactly 4/3 as fast. And that means that when it goes around 4 times, the other one goes around 3 times. Now, let's make 2 lines and draw this dot where the lines meet. We get this dancing dot around. And this dot comes from that number, right? Now we should trace it. Let's trace it and see what happens. This is what mathematics is all about. It's about seeing what happens. And this emerges from 4/3. I like to say that this is the image of 4/3. It's a very much nicer, thank you. And this is not new, this has been known for a long time. But, but this is 4/3. Let's do another experiment. Let's now take a sound. This sound. This is a perfect A, 440 hertz. Let's multiply it by 2. We get this sound. We play them together. Sounds like this. It's an octave, right? Now we can do this game. We can play a sound, play the same A. We can multiply it by 3/2. This is called what we call a perfect fifth. Sound really nice together. Let's multiply this sound by 4/3. Right? What happens? You get this sound. This is the perfect fourth. If the first one is an A, this is a D. They sound like this together. This is the sound of 4/3. What?
Flick to link, link to flick. My photo taste is the Pinterest because they are the best.
Welcome to Spotlight. I'm Liz Wade.
And I'm Bruce